For centuries, the scientific consensus has been clear. The Earth is an orb, a majestic sphere spinning through the vastness of space. This understanding has been supported by countless observations and experiments, from the ancient Greeks to modern-day astronomers. Yet a persistent group of individuals cling to the notion of a flat Earth, a disk encircled by an ice wall. Despite overwhelming evidence to the contrary, these flat Earth believers remain steadfast in their views. They conduct experiments, wielding their findings as irrefutable proof of this unfounded belief. These experiments range from simple observations to more complex setups, all aimed at challenging the established scientific view. But are these experiments truly scientific, or are they exercises in confirmation bias, desperately seeking evidence to support a predetermined conclusion? Many scientists argue that these efforts lack objectivity and are driven by a desire to validate preconceived notions. These experiments, often presented with an air of authority, unravel upon closer examination. The methodologies used are frequently flawed, leading to results that cannot be reliably reproduced. They lack the rigor of scientific methodology, failing to account for crucial variables, and often misinterpreting basic physics. This lack of rigor undermines the credibility of their findings. The results therefore are not surprising but rather predictable outcomes of flawed experimental design. These failures highlight the importance of adhering to established scientific principles. These attempts to disprove centuries of scientific knowledge highlight a fundamental misunderstanding of the scientific process itself. True science is about questioning and testing, but it also requires a commitment to objectivity and rigorous methodology. One of the most common experiments involves attempting to measure the Earth's curvature, or lack thereof. This has been a topic of debate for centuries, with various methods employed to either prove or disprove the curvature of our planet. Believers in a flat Earth often point to the seemingly flat horizon as evidence. They argue that the horizon always appears flat no matter where you are on the planet, whether you're looking out over the ocean or across a vast desert. They argue that if the Earth were truly curved, we should be able to observe this curvature over long distances. According to their perspective, the lack of visible curvature is a clear indication that the Earth is flat. To prove their point, some have gone to extraordinary lengths using lasers, telescopes, and even weather balloons to measure the curvature over miles of flat terrain. These tools are set up meticulously to ensure accuracy in their measurements. These experiments often claim to show no discernible curvature, supposedly debunking the spherical Earth model. The data collected is then analyzed and presented as evidence supporting their flat Earth theory. However, what these experiments fail to account for is the sheer scale of the Earth. The planet is so vast that its curvature is not easily noticeable over short distances. The Earth's curvature is subtle, especially over relatively short distances. It requires a much larger scale to be visibly noticeable, such as from high altitudes or space. The instruments used in these experiments often lack the precision needed to detect such a gradual curve. Advanced technology and precise instruments are required to measure the Earth's curvature accurately. Another experiment involves dropping objects from great heights, expecting them to land at an angle if the Earth were truly curved. The logic dictates that on a spinning globe, objects dropped from a significant height should land slightly to the east of their drop point. This expectation stems from a misunderstanding of the Coriolis effect, a phenomenon that does indeed cause moving objects to deflect on a rotating sphere. However, the Coriolis effect is most pronounced over long distances and at high speeds. The effect on objects dropped from heights achievable by amateur experimenters is negligible, far too small to be measured without sophisticated equipment. Section 4. Experts speak. The Earth is round. The scientific community is unanimous in its assertion. The Earth is an oblate spheroid, a sphere that is slightly flattened at the poles and bulging at the equator. This conclusion is not based on a single experiment, but on centuries of observations, experiments, and mathematical calculations. From the ancient Greeks who calculated the Earth's circumference with surprising accuracy, to modern astronauts who have witnessed the Earth's curvature firsthand, the evidence is overwhelming. Satellites orbiting the Earth, GPS technology, and even the changing seasons all provide irrefutable proof of our planet's spherical nature. Section 5. Trust the evidence, not the conspiracy. The allure of conspiracy theories lies in their promise of hidden knowledge, of being privy to a truth that the powers that be don't want you to know. These theories often captivate our imagination, making us feel like we are part of an exclusive club with special insights. However, clinging to these beliefs despite overwhelming evidence to the contrary can be detrimental. It can lead to a dangerous disregard for facts and a rejection of reality. It breeds distrust in legitimate sources of information and hinders our ability to think critically. This erosion of trust can have far-reaching consequences, affecting everything from public health to democratic processes. The shape of the Earth is not a matter of opinion or belief. It is a well-established scientific fact, supported by an overwhelming body of evidence gathered over centuries. From ancient astronomers to modern-day scientists, the evidence has been meticulously collected and verified. The pursuit of knowledge should be driven by curiosity and a willingness to accept evidence-based conclusions, even if they challenge our preconceived notions. Embracing this mindset allows us to grow intellectually and make informed decisions that benefit society as a whole.